Derivation of centripetal force. Let we say an object is moving the circular path, mass of the object is m, and it is moving circular path of radius r. After some time, let the object position is given by this, and you say this time is delta t, and let I say radius center of the circle is O, this point is A and this point is B. At point A, the velocity is given by v initial, at point B, velocity is given by v final. Both v initial and v final are same in magnitude, only direction is changing. That is also one of the important thing. And if I say object is changing A to B in delta t time, then arc length AB is written as v into delta t. Again we draw these two triangles here. This is initial velocity, this is final velocity, and this is delta t. And I say this is P, Q, R. And of course, both AOB and PQR are similar triangles. So if you compare ratio of the two sides, it should be constant because angle theta is same here and angle theta is same here. Same turning. So as you know, theta is known as the arc upon radius. Here arc length AB is given by V delta t and radius is R. And for this triangle, if we write this is the delta V, theta is known as the, so approximately it is given by delta V upon V, ratio of two sides. So we can write delta V upon delta t is written as V square upon R. And what is delta V upon delta t? That is the acceleration, and this acceleration is known as the centripetal acceleration. So centripetal acceleration is known as AC equal to V square upon R. This is the centripetal acceleration. Now we have to calculate the centripetal force. Force is given by mass into acceleration. So you will say mv square upon r. So this is the expression for the centripetal force, that F equal to mv square upon r.